Hi, I'm Cheryl Leach. In this problem, we're going to be looking at a related rate. Well, what is a related rate? Well, I see the word rate written there, and that makes me think of a derivative. But let's take a look at my problem, y equals the square root of x. Well, I know now that I can be talking about dy dx, but I could also be talking about dx dy. Related rates, though, are a special group of differentiation problems. When we're doing a related rate, we're not differentiating with respect to either the variables that are in this equation. We're going to be differentiating with respect to time. So I know that x and y are related to each other, and how they change over time will also be related to each other. So in the first example, I want to find dy dt when x is 4 and dx dt is 3. So I'm going to treat this just like I do implicit differentiation problems. I'm going to differentiate both sides of my equation, keeping in mind that I'm differentiating with respect to t. So the derivative of y with respect to t is dy dt. The derivative of the square root of x. Now we may want to think of this as x to the 1/2. And if we do that, we can take the derivative, and I'll get 1/2 x to the minus 1/2 power times the derivative of x with respect to t. So I'm going to have a dx dt as part of my chain rule. Differentiation is done. So I can find dy dt now, but I need a little information. I need to know what the x is and what the dx dt was. And that was given to me. So I'm going to do a little bit of algebra first of all, and write this as 1 all over 2 times the square root of x dx dt, and then plug in my given information. So I'm going to have 1 all over 2 times the square root of 4 times dx dt, which is 3. The little arithmetic, I can find that this is 3 all over 2 times 2, or 3/4. So that's dy dt. The next problem asks for dx dt, and it's going to be something different. Well, let's try our process again. I'm still going to use implicit differentiation. So what's the derivative of y with respect to t? Well, it's still dy dt. And the derivative of the square root of x with respect to t is still 1/2 x to the minus 1/2 dx dt. Notice that this part of the problem hasn't changed. However, the information we're going to substitute in is different. This time, the x is 25, and I know dy dt, which is 2. So again, let's do this little algebra rewrite where I make dy dt equal to 1 over 2 times the square root of x times dx dt, and then plug in my given information. dy dt is a 2. X is 25. And I'll be multiplying by dx dt. So I have 2 equals 1 over, well, the square root of 25 is 5, so 2 times 5 is 10. So I've got 1/10 times dx dt. This time I'm going to have to solve for the dx dt. But that's not a difficult problem. All I need to do is multiply both sides by 10. And dx dt is going to be 20. I hope this was helpful. Thanks.